Section 8.1 is on page 421. It's an introduction to Taylor polynomials from second semester calculus. If you recall, so normally we call them T sub n in certain books. Here they call them P sub n for polynomial, T for Taylor. So a Taylor polynomial, if you recall, if you want to find the center of a function around x sub 0, it's f of x sub 0 plus f prime of x sub 0 times x minus x naught plus f double prime of x sub 0 times x minus x naught squared over 2 factorial. The third derivative, x minus x naught over 3 factorial, and so on. So here we're just going to recall some of this. Now we're going to do 8.1 today. You should review the radius of convergence by using the ratio test for 8.2 before I go over it next week. So starting with the first problem, it says, this is on page 425, determine the first 3 non-zero terms in the Taylor polynomial approximation of the given initial value problem. This is a differential equation of order 1. This is the initial condition. So if I really wanted to find a polynomial evaluated at, in this case, at 0, that's going to be f of 0 plus f prime of 0 x to the 1 over 1 factorial f double prime of 0 x squared over 2 factorial, if you recall that. Now how many of those do we need? Well, we only need, in this case, we just need to run until we get the first 3 non-zero terms. Now, you'll notice those don't change, if you remember. That part is simple. The tough part was figuring out those coefficients. And so on and so forth. Well, they gave us the first one. They said f of 0 is 2. We got 1. We need 2 more. So if I take y of 0 equal to, or f of 0 equal to, whatever you want to call it, if I take a derivative of this, that is y squared. That's right there. And if I figure out what is y prime of 0, that's when x equals 0, that will be 2 squared, which is 4. Hey, I got another one. I just need one more. So I need a second derivative. Again, this is f prime. If you take a second derivative, that is 2y y prime. That is 2 evaluated at 0. Y is 2. And y prime is 4. That makes it 16. So I really don't need to go on. I would say the P sub 3 is 2 plus 4x plus 8x squared. And that's pretty much all I need. This is an approximation, third degree of this differential equations. And that's pretty much all there is. Of course, the list goes on, but we're only interested in the first 3 non-zero terms. This is infinite. You could go up as high as you like, right? So we're going to do that again. We have a first order differential equation right there. And we know that y of 0 is 0. So here we're out of luck, because we're going to say this is f of 0 plus f prime of 0 times x. Again, it's centered at 0. And we're not sure how many of those we need. So for starters, that's gone. That's not sufficient. So we need more terms. Well, let's see. We know that y prime equal the sine of x plus y. And that's right there. Again, that's a given. Well, if I substitute x equals 0 in there, I'm going to shift this a bit to the left so it fits. So if I evaluate this at x equals 0, if I evaluate this at x equals 0, and in this case y sub 0 is 0. That's the sine of 0 plus 0. That's a 0. So out of luck on the second term. The second term is also 0. Well, how about the third term? What if I take y double prime? Y double prime in this case would be the cosine of x plus y times 1 plus y prime, and let's see how this plays. Now, if I replace x by 0 and y by 0, and y prime we got it to be 0, this is a 1 times 1, that's 1. So there, I got one term so far. I need two more. If I take a third derivative, in this case that's going to be negative the sine of x plus y times 1 plus y prime plus the cosine of x plus y, derivative of the first times the second plus the first, and the derivative of this will be 0 plus y double prime. And if I evaluate that, that is negative the sine, and those are 0 plus 0, so this whole thing is 0, plus cosine of 0 plus 0, y double prime, we got it to be 1, so that is 1, that's also a 1. Well, I'm in luck, because now I know that this is so I still need one more term to go. If I take the fourth derivative, so you see where the messiness is here. If I take the fourth derivative, that would be, well, this is going to be a bit of a work. Let's see. Derivative of the first times 1 plus y prime squared minus the sine of x plus y. Derivative of the first, nope, I missed it. Derivative of the first times the second. The second is 1 plus y prime squared plus the first times derivative of the second. Remember, this is going to be this thing squared, so you bring the power down, subtract 1 from the power, times y double prime, product rule, minus the sine of x plus y times 1 plus y prime times y double prime plus the cosine of x plus y times y triple prime. Now, if I replace x by 0 and y by 0, that is a 1. Y prime was 0. This is a 0, so all of that is gone. This is a 0, so all of that is gone. And this is cosine of 0 plus 0, that's 1, times y triple prime, which is 1. So here I'm looking at the first times the second. That turns out to be a 0, so out of luck. Well, one more derivative, that's the coefficient of the fifth. Let me see if I can clean this up. This is negative the cosine of x plus y times 1 plus y prime cubed minus twice the cosine of x plus y times 1 plus y prime times y double prime minus the cosine plus the cosine. Okay, well, if I take a derivative of that, that's going to be the sine of x plus y, but isn't true whatever I multiply that with is going to be 0, minus the cosine of x plus y times the derivative of this, 3 into 1 plus y prime squared times y double prime. That part is done. If I get to this part, that's going to be negative the cosine of x plus y times 2 into 1 plus y prime times y double prime, and here comes the messy part, times a negative sine of x, oh yeah, I don't have to worry about that part. Derivative of the first times the second, plus the sine of x plus y. Now the derivative of this is a big mess, but I'm multiplying that by 0, so it doesn't matter. And this piece, I'm going to get negative the cosine of x plus y times 1 plus y prime times y double prime, minus the sine of x plus y. And again, the derivative of this is multiplied by 0, so it's not going to matter either. And the last, negative sine of x plus y times y triple prime, that's a 0, plus the cosine of x plus y times y to the fourth derivative. And if I plug in 0, what do I get? I get a 0 minus 1 times 3 times 1, and y double prime was a 1, okay, minus cosine, that's a 1 times 2 times 1 as well, that's a 0 minus the cosine, so that's a 1. Now I'm down to this, that's a 1 as well, plus a 1. Let me just make sure I didn't mess up the signs. Negative 0, that's a negative. There's the sign, is okay. Minus, yeah, that's right. Okay, so what do we get? Whatever that number is, I think that's a plus. I can't find a mistake, but I think that's a plus. But whatever number I get, so that's negative 3. Those two cancel out, I think plus 2. And if it was a minus, that would be a minus 5. It doesn't really matter. So that's a minus 5. So when you come up here, you say minus 5x to the 5th over 5 factorial. These are the three terms. Now if you just clean it up a bit, and there's my answer. It's going to be x squared over 2 plus x cubed over 6 minus x to the 5th, 5. 4 factorial is 4 factorial, that's 24. So there it is. And that will be the answer. So it's not that complex, just this derivative is kind of messy. Most of those are really straightforward. So here now we're doing a second order differential equation. The same deal. I still want f of 0 plus f of 0 times x to the 1 over 1 factorial plus f double prime of 0 x squared over 2 factorial. Again, I don't know how many of those I'm going to need, but the list goes on. So y of 0 is 0, out of luck on the first term, but the second one is a 1. That's very good. And now I'm going to go for the third one, and let me see what that is. If I take y prime of 0, that's a 1. Y double prime is negative y. That is a 0 as well. And if I take a third derivative, that's negative y prime, that's negative 1. So that's a coefficient of the third derivative. If I take the fourth derivative, that's minus y double prime. Y double prime was a 0, out of luck. And if I take the fifth derivative, that is negative y triple prime. Triple prime was a negative 1, so that's a 1. So I could say the third degree polynomial in this case happened to be, or the first three terms of this polynomial, it's an infinite polynomial, it's x minus x cubed over 3 factorial is 6 plus x to the fifth, and 5 factorial is 120. And so here we're approximating the solution by 3 terms, and we'll talk about what that means when we go through the rest of chapter 8. Okay, here the same deal. I'm looking at y of 0 is 1, that's good. Y prime of 0 is 0. Y double prime is negative the sine of y, right? Just move that over. So this is going to be the polynomial p sub n is going to be y of 0 or f of 0, whatever you want to call it, f prime of 0, x to the 1 over 1 factorial, f double prime of 0, x squared over 2 factorial, triple prime of 0, x cubed over 3 factorial. I need the first 3 non-zero terms. And you notice they're all centered at 0. If it was centered at anything else, it wouldn't be that much different. So I already have a 1 right there, but I have a 0 x to the 1 over 1 factorial. Now if I plug in x equals 0, sine of 0 is 1, so that's negative the sine of 1. Okay, that's good. Plus, oh, minus actually. Sine of 1, you could plug that in the calculator if you want, but you could leave it like that. And if I take another derivative, that will be negative the cosine of y times y prime, but y prime is 0, so that's 0. And if I take the fourth derivative, that would be negative the sine of y times y prime minus the cosine of y times y double prime. Well, that's negative the sine of 1 times y prime, which is 0. Minus cosine of 0 is 1, right? So y of 0 is 1, you put a 1 there, and y double prime is negative the sine of 1. So good, that's a 0, but I got a plus cosine of 1, sine of 1. This is the coefficient of x to the 4th over 4 factorial. So the first 3 terms of this infinite sum, I keep on ending it. There are an infinite amount of terms. I'm just choosing the first 3 because that's all they ask for. Minus the sine of 1 over 2 x squared plus the sine of 1 cosine of 1 over 4 factorial is 24 times x to the 4th, and the list goes on, but that's all what I need. And that would be my solution. And that's it pretty much for this section. You should review the ratio test for the next section, which will be in the next lecture.